Welcome to my video on solving practical inequality word problems. So the steps are identical to the multi-step word problem equation steps that we had when we solved multi-step equations. So we first have to read the problem, underline key words, define the variable, in other words, what are we looking for, and write the inequality. Solve your inequality. Analyze your answer, does it make sense? Okay, let's look at the first problem. Daniel had $25 to spend at the fair. If the admission to the fair, let's go back and underline this. If the admission to the fair is $4 and the rides cost $150 each, what is the maximum number of rides Daniel can go on? So we want to know the maximum number of rides he can go on, so we're looking for R equals rides. So let's set this up. We know the admission to the fair is $4 plus $1.50 for each ride. So I would take $1.50 and multiply by the number of rides I went on. And he has $25 to spend. So the maximum number that is less than or equal to 25. Okay, let's solve this. This is a two-step inequality. So circle your variable and draw your t. If we want to get rid of positive 4, we have to subtract 4 from both sides. 4 minus 4 is 0. Cross it out. Bring down the $1.50 R. Bring down your inequality symbol. And 25 minus 4 is 21. I have one last step because I still don't have R by itself. The opposite of multiplication is division. So we're going to divide both sides by $1.50. $1.50 divided by $1.50 is a 1 in disguise. So R is less than or equal to 14. And we just have to make a statement that answers the question. So what is the maximum number of rides Daniel can go on? So we can say at most 14 rides, meaning he can go on 14 or less. He doesn't have to go on all 14, but if he chooses to, he can. Okay, and that would be reasonable if you were spending $1.50 each and a $4 fee. 14 rides would make sense. It's reasonable. So let's look at number 2. Last year, 7th grade students sold candy bars for a fundraiser. Let C represent the number of candy bars sold last year. Okay, so it's telling us what letter to use, so I'm just going to write it now. C equals candy bars. This year, 7th grade students would like to sell 50 more than, I'm going to circle that because it's a switch around word, twice the number of candy bars sold last year. The sales will not exceed $300. That means it won't go over $300. How many candy bars would you expect this year? 7th graders to sell. So we know it's not going to exceed 300, so that's going to be what our inequality is going to be. So we have to write 50 more than twice the number of candy bars, so 2C plus 50. And if we don't want to exceed 300, we have to be less than or equal to 300. We don't want to go over 300. So circle your variable and draw your t. The opposite of adding 50 would be subtracting 50. 50 minus 50 is 0. Bring down your 2c. Bring down your symbol. And 300 minus 50 is 250. The opposite of multiplication is division. So we're going to divide both sides by 2. 2 divided by 2 is a 1 in disguise. So bring down your symbol. And 250 divided by 2 is 125. So I said, how many candy bars would you expect this year's 7th grade to sell? 125 candy bars or less. So we'd expect them to sell 125 or less. Okay, and is that reasonable if 50 more than twice? Yeah, that is a reasonable answer. So let's go on to the back. Easy Car Rental charges $15.50 a day plus a one-time charge of $10. RB Car Rental charges $18.50 a day plus a one-time discount of $14. After how many full days is Easy Car Rental a better deal? Okay, so we want to know number of days, so D equals days. So we know how much Easy Car Rental is, $15.50 a day plus a one-time, whoops, hold on one second. We want to do $15.50 a day, which means we would have to do $15.50 times the number of days plus a $10 charge. That's a one-time charge. Now we want to find the better deal. So we want to know when this is cheaper, right? So we want to know when this is less than RB Car Rental. So $18.50 a day. So we're going to multiply by the number of days. And then a one-time discount. Remember, discount makes your bill go down, so we have to subtract $14 discount. Okay, now our first step when we have variables on both sides is to get the variables on one side. I always like to keep it positive, so I'm going to move this one. If you wanted to deal with negatives, then you could have moved the $18.50. Now, these cancel out. Bring down your $10. Bring down your symbol. $18.50 minus $15.50 is $3. So I'm going to write 3D minus 14. Now we have a two-step inequality. Circle your variable, draw your T. The opposite of subtracting 14 would be adding 14. Fourteens cancel. 10 plus 14 is 24. Bring down your symbol. Bring down your 3D. And the opposite of multiplication is division, so we're going to divide both sides by 3. 3 divided by 3 is a 1 in disguise. 24 divided by 3 is 8. Bring the symbol straight down and bring your letters straight down. Now, remember, we can always read it backwards, so D is greater than 8. Okay, it has to be greater than 8, and it can't equal 8. And I want to know how many full days. So we could say our statement would be after 9 or more days. Okay, let's look at example number 4, which is our final example here. It says 2 consecutive even integers are such that their sum is greater than 98 decreased by twice the larger number. So we have 2 consecutive even integers such that their sum is greater than 98 decreased by twice the larger number. Find the smallest possible value for the integers. Okay, so we're looking for two consecutive even integers. So we could say x equals the first integer, which of course would be the smaller one. And then if we're doing consecutive integers, that's one after the other. So if we had any integer here, 2, how could we get to the next even integer? We'd have to add 2. So x plus 2 equals second integer. And this, of course, would be the larger one. Okay, and we want their sum to be greater than 98 decreased by twice the larger number. So we want to add x plus 2. These are the two consecutive integers. And we want it greater than 98 decreased by twice the larger one. Now this is the larger one, and remember it's x plus 2, so we have to put it in parentheses because we want to twice it. Okay, now the first thing we want to do is combine like terms and do the on one side and do the distributive property on this side. So here's my like terms. X plus x is 2x plus 2 is greater than. Now I have to do the distributive property here. Negative 2 times x is negative 2x, so minus 2x. And negative 2 times 2 is negative 4, so minus 4. Now I see that I can combine these two, so I need to use the commutative property. 98 minus 4 minus 2x. Now I can combine these. 98 minus 4 is 94, so 2x plus 2 is greater than 94 minus 2x. Okay, now, if I want to keep a positive variable, I need to add 2x to both sides. These two x's are going to cancel, and 2x plus 2x is 4x plus 2 is greater than 94. Circle your variable and draw your t. The opposite of adding 2 would be subtracting 2. 2 minus 2 is 0. Bring down your 4x. And 94 minus 2 is 92. Not done. We got to divide both sides by 4. 4 divided by 4 is a 1 in disguise. So x has to be greater than 23. Now, what is the next greater number, even number after 23? The answer is 24. And remember, I wanted consecutive even numbers. So my first one is 24. I have to add 2 to get the second one. So it's 24 and 26. So box this in. And that would be a reasonable answer. So that concludes our notes on solving practical inequality word problems. I hope you have a great day.